Hi folks, so today we're going to talk about how to use the Define Projection tool versus the Project tool in ArcMap. So before we do that, here's a flash review about geographic data and the terminology that ArcMap uses and how it behaves. So all geographic data is collected in a geographic coordinate system that allows us to locate a place on the Earth's surface. So most commonly used, very commonly used geographic coordinate systems, or GCSs, are WGS 1984, or World Geodetic Survey 1984, or NAD 1983, North American Datum 1983. When we apply a projection to geographic coordinate systems, ArcMap calls that projected coordinate system. Now, a projection allows us to take a 3D object, the Earth, and display it on a two-dimensional surface. So projections such as Albert conformal conic or state plane systems are used to project data. So ArcMap shows you geographic coordinate systems and projected coordinate systems, or PCSs. So for example, for Orange County, we have a state plane system, projected coordinate system, that uses GCS NAD 1983, or the geographic coordinate system of NAD 1983, and a Lambert conformal conic projection. So it's important to note that when you add your first data layer or feature class to ArcMap, that sets the coordinate system, the either geographic coordinate system or the projected coordinate system of the data frame, so that the data frame can then decide, when you add subsequent layers, whether it can align those layers, what's called on the fly. And it can do that if you have, for example, layers that are in different projected coordinate systems, but that use the same geographic coordinate system. So again, all data are collected in some geographic coordinate system. So all projected coordinate systems have both an underlying geographic coordinate system, such as NAD 1983, in addition to their projection. So ArcMap tries to project on the fly, and it can do that if you have all of the data layers in the data frame in the same underlying geographic coordinate system. If you try to add a layer that's in a different geographic coordinate system, you will receive a geographic coordinate systems warning, and that's when you use the project tool. The project tool then transforms a data layer, or a feature class rather, from one geographic coordinate system to another. On the other hand, we have the Define Projection tool, and the Define Projection tool is used when ArcMap cannot find the spatial reference information for a particular feature class that you're adding, or data layer that you're adding. So you have to know what geographic coordinate system or projected coordinate system a particular data set has in order to use the Define Projection tool. So for example, shape files have numerous files that are associated with them, one of those being a .prj, or projection file. If somehow that gets deleted, you might get a unknown spatial reference warning from ArcMap, and in that case you would use the Define Projection tool. Okay, so we're going to see how this actually works in ArcMap now. So here we notice a folder that has multiple data sets in it. Here we have Colorado County's shapefile. If you right click and go to the properties of this shapefile, you'll notice that it actually has an unknown coordinate system. So what's going to happen when we try to add this layer to ArcMap? ArcMap gives an unknown spatial reference error. It says the data source is missing spatial reference information. It can be drawn, but it can't be projected. So I'm going to click OK, and I just happen to know that this is collected in a particular PCS. So I'm going to use the Define Projection tool to tell the program what projection is used by this data set. And we use the Data Management tool here. Note that if you don't know which of these to select, you can always click on the information, this description underneath a tool, just to verify. So here we're going to select Colorado counties as the input data set, and we're telling the program that this is the data set or feature class whose projection is going to be defined. It's currently unknown, and it uses a USA contiguous Albers equal area conic. And you can see the define projection tool working here. And if this tool works properly, we should have this layer now have a spatial reference associated with it, or the correct spatial reference. So now you can see under the layer properties that this does now have this projected coordinate system, which uses the geographic coordinate system, the underlying geographic coordinate system of the NAD 1983. So just to double check this, let's click out of ArcMap. We're not going to save any changes. And then when we go back into ArcMap, let's see if this problem has been fixed. Apologies for the slow computer. So we're going to open up a blank map, and we can go back to the folder where we have the data stored. And we have Colorado County's shapefile. And now it's added. We didn't get a warning, and let's see if it has been. Yes, the spatial reference data has now been saved into the shapefile. And again, we now can draw this with no problem. Now, the other thing to note is this is the data frame properties. So what we didn't check before adding this first layer was the data frame properties. But when you open up a blank map, a brand new map template, there is no coordinate system. Now that we've added our first layer that has a projected coordinate system, ArcMap has changed the data frame properties to match this first layer. So now you can see that the data frame has the same USA contiguous Albers equal area conic PCS, or projected coordinate system. So now when we add subsequent data layers, it's going to use that NAD 1983 coordinate system. And if we try to add a different GCS or a file with a different GCS, it's going to give us the coordinate system warning. So let's take, for example, the city's shapefile. If we look at the properties for the city's shapefile, we see GCS WGS 1984. So this is a geographic coordinate system, and it's not the same as the NAD 1983. So if we add this data file, we expect that we're going to get a geographic coordinate systems warning. And there it is. It's telling us that this data source, the city's data source, uses a geographic coordinate system that's different from one that's used by the data frame. And we know we just checked the data frame is using that projected coordinate system that has the underlying GCS NAD 1983. So rather than transforming using the data frame, we're going to close out of this and use the project tool to change, or rather to create a new data set of this city's file that's in the same GCS as this Colorado counties layer. So we're going to use this project, again, data management tool. And we're going to tell it that we want to input the cities layer and create a new cities layer that is in a different GCS. Here it's asking me, where are you saving and what are you calling this new data set? I'll go ahead and just save it into the default geodatabase, since I didn't change what the default geodatabase is, and I forgot to name it. So let's call it cities NAD 1983. Making all sorts of mistakes here. NAD 1983. And the output coordinate system that I can use, I could go and use the entire PCS that's used by this Colorado counties layer. But I don't have to do that. I could just use the GCS. Let's go ahead and make it in the same PCS. It's best practice to keep all of your data sets, especially if you're doing spatial analysis, keep them all in the same GCS or PCS. And usually these are ordered from most appropriate to least appropriate transformations. We're going to select the top one as most appropriate. And then when we click OK, you'll see the project tool running. And when it's done, it should have added the data set here. If not, if it didn't automatically add, you can always manually go to wherever you saved it, the default geodatabase in this case, right? And you'll find that data set here. And if we right click, we can look at this, the coordinate system, and you'll see that indeed this is the newly saved or newly created version of this city's layer, and it's been added here. I can remove the old version and completely remove it from the map. And then go to the properties here, and we've got two layers that are in the same projected coordinate system. And of course, the data frame took on the first coordinate PCS of the first layer that was added, which was that Colorado counties. And so it's this same PCS. All right, so as a summary, we talked about the project tool being useful when you get a geographic coordinate systems warning, when you have two different layers or multiple layers that are in different geographic coordinate systems, and you want to create a new data set to align with another geographic coordinate system. And the define projection tool, which is used to tell the program what the GCS or PCS of a file is. So you have to know the associated information, and you might get an unknown spatial reference warning telling you that the spatial reference information is missing. And that's when you would use a define projection tool. Very importantly, though, I'll finish with, don't trust ArcMap to alert you to a problem. Or don't wait for these warnings to appear. Always check your coordinate systems for each of your data sets and know what you're adding to your data frame, and anticipate these problems rather than relying on ArcMap's warnings. All right, good luck, happy mapping.